Okay, I am recording this one. I didn't love my second hour recording, so I'm going to record this one again and post this one. I do see that there are people with us though, so that's exciting. Okay, all right, so what I need you guys to do is go do your attendance question in your module. So yesterday you had your Edulastic quiz. I didn't hear from any of you guys via email, so I'm guessing that went well, fine. I have one student I know that wasn't able to access it, so he is working on that. I've given him until the end of the day to do that, and then I will be releasing those scores. So I know a lot of you want to know how you did, what you got on there, but I can't release that until he is finished. And there may be a couple more people that are reaching out to me. I have 0 emails at this point, so that's good. I know that says 68, but that's a lie. I answer them on my school email, and so that's there. So y'all do that attendance real quick. Let me do the attendance on my side, and then we will get going. Are y'all excited about coming back? Y'all think it's going to be better having school 4 days a week? I think so too. Christian, he checked out. Connor, gotcha. Hudson, Bennett, gotcha. Xavier, Tyler is out, and Morgan. That's you. All right, I got my group. Okay. So we are on Tuesday, lesson 4.1. So we are starting a new lesson. Now, what's kind of funny about this, maybe not really funny, but when Gracie was in the hospital and you guys were abandoned by me, I gave you a worksheet on segment addition postulate, and you like had a YouTube video that you could watch. Well, this is kind of what this lesson is on. So some of this you're going to have already figured out on your own because of that worksheet, but I do want to cover it and make sure I don't just skip this lesson, because there is some stuff on here that you're going to want to know, okay, especially dealing with the midpoint. So if you look at the top of this page, it says that lesson 4.1 is about segments and midpoints. That's not what I wanted. Is this the right? Yeah. This is what I want. Segments and midpoints. Okay, so we are going to have 2 learning targets. The first one says apply the segment addition postulate, which is what I made you guys just figure out on your own. We talked about it a little bit in the geometry basics that we did at the very beginning of the year, and then y'all had that worksheet where you kind of self-taught yourself. But from looking at it, it looks like you guys did pretty good. And then use the definition of midpoint to find lengths of segments. That's going to be the new information that you haven't done yet, okay? All right, so this whole first page is just talking about distances and measurements. So we're going to kind of just read through this pretty quickly, and then we'll talk about some more things on the next page. So it says, in geometry, axioms and postulates are statements that are accepted as true without proof in order to provide a starting point for deductive reasoning. Like point, line, and plane, distance along a line is an undefined term in geometry used to define other geometric terms. For example, the length of a line segment is the distance between the endpoints. If 2 points are no more than 1 foot apart, you can find the distance between them using an ordinary ruler. So they've got a ruler there for us. They've kind of shrinked it down so to fit on the page. But if you're looking at endpoints A and B, what's the distance between A and B? 5 inches. Now look below that at A and B again. It looks like they've just taken that ruler and kind of slit it down a couple units. So now it's got an endpoint at 2 and an endpoint at 7. Well, what is the distance between those two endpoints? Still 5 inches, still 5 units. So when you're dealing with something and you're trying to find the distance between those, what you're going to do is use the absolute value difference. And it doesn't really matter what endpoint you use first. Okay, if you look at their little example right here, you can see they have 7 minus 2 in absolute value. And you can also see they have 2 minus 7 in absolute value. Either way, it's going to give you 5 because the distance, you guys, is not measured in negatives and positives. Distance just is how many units from one point to another point. Just like if I was going to my house is 12 miles away from here. If I was coming from my house to Bird, it's not negative 12 miles, it's still just 12 miles. It doesn't matter the direction that you're traveling, you're just looking for a distance. There are no negative distances, okay? Now, this is important to note. It says AB, just plain AB, denotes the distance between points A and B. So if you don't see a bar on top of it, if you don't see any kind of, you know, something to kind of set it apart, if it literally is just a capital letter next to a capital letter, you're looking for the distance between those two letters. It says if A and B are the endpoints of a segment, line segment AB, then AB denotes the length of line segment AB. So if you're just given the letters, then they're looking for the distance between those 2 points. Okay? All right. Now, we're not actually going to do this because I'm not going to pass out the rulers because coronavirus. So we're just going to kind of talk about this. If I was to get a ruler out and measure DE in inches, and let's just say it's 2 inches, okay? Is that going to be the same thing in centimeters and millimeters? Would it still be 2 centimeters and 2 millimeters? No. Okay, so when you're measuring something out, you need to make sure you're dealing with the correct units. And then when you are dealing with a situation, especially word problems, they will kind of put that in play sometimes, and they'll give you something in the word problem. They'll say blah, blah, blah is 2 inches and blah, blah, blah is 24 centimeters. Okay, so you have to do that conversion to make sure you're dealing with the same units. Okay, so just keep your eyes open for that. Make sure you're looking at the units, make sure you're doing it in the correct units, and know, like, okay, I can make my conversion and know that 1 inch is 10 centimeters. Is that correct? Let me look on this. 1 inch is not 10 centimeters. So it's like 2 point something. Yeah, so this is wrong. So we might want to Google that one, but it's going to be like 2 point something centimeters. And then you would say, okay, well, 1 centimeter is equal to how many millimeters? That's 10, isn't it? Yeah, that's 10. So just make sure you know your conversions. Those all out there in Google, that's definitely there for you, but make sure you're able to recognize when you need to make a specific conversion. Okay, flip the page. We are going to skip down to number 4, okay? Because again, that other stuff is asking us to use a ruler, and we are not getting out the ruler. So we're just going to go to number 4. Now, number 4 says, given that N is a point between endpoints M and P. So it doesn't say it's the midpoint. It doesn't give you anything specific. It just says it's a point. So we could draw this out, and everyone could draw it out differently, and that would be okay. I'm going to make sure it doesn't look like the midpoint. Okay, so that is my N. It says describe how to determine the length of MP without measuring if you are given MN and NP. MN and NP. So this is kind of what you did without me. How were you able to determine the entire length when you had the smaller parts? Good. So I'm looking for that combination. If you know what NP is, the distance between NP, you can add that to the distance of NP. Did I say that wrong? MN. Take the distance of MN, add it to the distance of MNP. Oh my gosh. And it equals the entire distance MP. So it's like little plus little equals the big. And like Marion was saying, if you have the big one, then you end up subtracting, okay? So that's kind of working backwards with the segment addition postulate. But our segment addition postulate is this. You take the little segment, you add the little segment, and it equals the big segment. Little plus little equals big. And then you just work it out depending on who you know. Sometimes they give you the big part. Sometimes they give you both of the small parts. Sometimes they give you numbers. Sometimes they give you variables. It all just depends on what your problem is, but you can use this postulate every single time to solve out your problem. So here are some examples for us. Hey, how are you? This is my boss. We're Zooming right now. He is my boss. He may not say he is, but he totally is. Okay, y'all. So we look at number 5. I for sure am a visual learner. So when I read this, they did not give us a picture here. Okay, so what I'm going to do is I'm just going to sketch out to the side my own number line, just because it makes it a little bit easier to see visually. So it says if B is between C and D. So endpoint C, endpoint D. B is somewhere in the middle. It doesn't say it's the midpoint. It just says it's somewhere in between. So you put it wherever you want it to be. I'm going to put it right there. Okay, because it's just a sketch. It's not like, this isn't like exact, accurate. It just is a sketch. Okay, so BC. Is that the same thing as CB? Yeah, doesn't matter. It's just the distance between those 2 points is 10 inches. Then we have BD. The distance between those is 3. Now, my picture's not quite accurate, but again, it's just to help us visually. It doesn't have to be perfectly accurate. It's just so we can see it. So what's CD, the distance between CD? 13. And you got that using the segment addition postulate. It's so easy that you're not thinking about that, but what you just did is you took CB plus BD and you got CD. So you're using that postulate even if you're not realizing that that's what you're doing. So you try B. Yeah, I mean, let me turn this off for a second. let's change this up. Well, that's what I get for trying to like cheat. It doesn't look very good, but whatever. So we've got RT, and then we've got, who's in the middle? Q. All right, so RT, the whole thing is 24, and then QR is 6. So how would we find that missing piece? Yeah, you've got to subtract. So you're going to do 24 minus 6, which is 18. So you know that's going to be 18. We're still using that same postulate, you guys. We're still saying RQ plus QT equals RT. The only difference is this time they gave you RT and they gave you QR. You had to work backwards to find QT. Make sense? It's really not crazy yet. So, okay, let's look at C. If we look at C, it tells us that L and A are our endpoints, and that P is the midpoint, or not the midpoint, just in between, okay? So we're going to say, okay, PL is x plus 4. So I already know we're going to be dealing with algebra because we have an unknown. Then we have PA, which is 2x minus 1. And they tell us the whole thing, LA, is 5x minus 3. So we are going back to that postulate. We know little plus little equals big, okay? The little segment and the little segment together give you the entire segment. So you just plug in what they represented. This time they didn't represent it with like numbers. They have expressions. So we've got x plus 4 plus 2x minus 1 equals 5x minus 3. Does that make sense? All right, so then we just solve this just like we're in Algebra 1. Going to combine my like terms. I've got an x and a 2x, which gives me 3x. And then I have a 4 and a negative 1, which gives me positive 3. That's all right. On this side, we've got 5x minus 3. Okay, I got to have more space, so I'm going to come up top. All right. What do you want me to do next? Add what? This 3 that way? Okay. So that gives me 3x plus 6 equals 5x. Now what? Subtract 3x. Then by 2, so x equals 3. Now, is that what we're looking for? It's part of it. So we've got our x equals 3. Now, how do we get our LA? Thank you, sir. He's exactly right. You just plug it in. 5 times 3 is 15 minus 3 is 12. Everybody okay with that? So that's what I pretty much made you learn on your own. Okay, so hopefully when you did that worksheet, you kind of felt comfortable. If not, hopefully that kind of cleared some things up for you. It just was completion on the worksheet that you turned into me. So hopefully this is going to help you master this. Okay, now page 41. This is where we're going to start talking about the midpoint. Okay, on page 41, it says the midpoint of a segment is the point on the segment that divides it into 2 congruent segments. For example, B is the midpoint of line segment AC. Then line segment AB is congruent to line segment BC. So they are telling us this is the midpoint. So since that's the midpoint, that's why you can see those are going to both be 3, which means they are congruent. So you can set up a congruency statement like that. So here's an example, number 6. Given M is the midpoint of RS. I'm going to draw that out because like I said, I'm a visual learner. Now, I am trying to get that to be the midpoint. Okay, it may be off some, but I'm trying to make sure that this is the midpoint. All right. Because I know that's the midpoint, I know that RM is going to be congruent to MS. Okay, because it's the midpoint. So now let's look at what they tell us. They tell us that RS is 10. Okay, so RS is 10. That's the whole thing. So they want to know what is SM. So what would the little be? Well, and how do you know? You break it into 2 equal parts. The only way that we can take 10 and split it equally is for each side to be 5. So that means this would be 5 and this would be 5. Okay? All right, B. B tells us that RM is 12. Okay, so RM is 12. So what does that make MS? 12, because they're going to be congruent to one another. So that means MS is 12. So what does that make RS? 24. Okay? Everybody okay with that? Let's check our understanding real quick. Number 7, points D and E are aligned with a ruler. Point D is at the mark for 4.5 centimeters. The distance between point D and E is 3.4 centimeters. At which 2 marks on the ruler could point E be located? Now, go ahead, say that again. Good, and how did you get both of those? But then you also subtract. Very good. Okay, so you're going in 2 directions. You could add the 3.4. So what's 4.5 plus 3.4? Okay, so that's one option. That would be somewhere over here. Then the other option is to subtract. So we would have 4.5 minus 3.4. And what's that going to be? 1 point what? 1.1. And so that would be somewhere over here. So when you're doing the distance and you're dealing with a number line, you can have the same distance on either side, both ways. Okay, so that's how you would adjust for that. Number 8 says point N is the midpoint of FG, line segment FG. If FN is 2x, what expression represents FG? Is it the midpoint? Okay, so we know that FN is 2x. What expression would represent this entire segment? 4x. And how could you get 4x? So you could just add it to itself. 2x plus 2x equals 4x. Or what's the other option? Well, no, that's okay. I mean, it makes sense mathematically, but if they just tell us 2x, multiply by 2, double it. That's what I want you to see, because in a second, we're going to need to be able to double things. So if you know one of the little segments is 2x, then you can double it. And that also gives you 4x. Okay? So that's that. Number 9 says, does a ray have a midpoint? So if you have a ray, is there a midpoint to that ray? Why not? That's right. Okay, no, because one side is going to infinity. I guess I should put like goes to or something. All right, so number 10. Give an example that illustrates the segment addition postulate. Sketch, include a sketch of your example. let's just skip that one. But like if we were going to do that just real quick together, you could just give me, you know, this is 4, this is an unknown, and the whole thing is 10. Okay, and then you could work that example out. It could be anything, but I want us to keep moving because we have so much more to do. Okay, so look at number 11. Number 11 says you can also use a number line to find the distance between 2 points. Okay, this is kind of like what we were talking about with the ruler, but instead of it being a ruler, now we're dealing with a number line. So how would you find the distance on a number line? You could count as long as they're counting by ones, or you could use the absolute value difference, just like with a ruler. Okay, so Christian is right in the fact that for this one, it's very easy for us just to say 1, 2, 3, 4, 5, 6, 7. So 7 units. But it doesn't always count by ones. Okay, so if that's the case, then you need to do the absolute value difference. What is -3 minus 4? What's the absolute value of -7? So 7 units. Or you could say 4 minus -3. What's minus negative? So what's 4 plus 3? What's the absolute value of +7? Still 7 units. So no matter if you count it out or if you do the absolute value difference, either way, you're still going to get 7 units. Okay, so don't forget about that absolute value difference. All right, now, this says the midpoint of a segment is halfway between its endpoints. So if you know the coordinates of the endpoints, you can average them to find the coordinates of the midpoints. What's it mean to average something? That's right. Add them up, then divide. So when we're dealing with endpoints, how many endpoints are we going to be dealing with? 2 endpoints. In this case, 8 plus 40. So you would add your endpoints together. What's that going to give you? 48. And then we would divide by 2. What's 48 divided by 2? 24. So where's the midpoint? 24. Okay, that is your midpoint. Now, you've got the coordinate of the midpoint. It's at 24, so you know it's at 24. The distance between those two is 16. Do you see 16 counters? No. Okay, so like I said, you can't always count the counters because it's not always going to be just a single one. So what you could do to find the distance is you could do the absolute value. 8 minus 40. What's 8 minus 40? -32. What's the absolute value of -32? That's the whole segment. The distance between your endpoints is 32. So the distance between the midpoint and an endpoint is half of that, which is 16. Okay, so that's how they got the 16 and 16. All right, look at number 13 in the check your understanding. Okay, it says use the number line to solve each problem. So you've got 4 things based on that one number line. So I'm going to give you guys a second to work out that, and then we'll talk about each one. So go for it.
Miss Cole,
Yes.
when are you gonna put the YouTube video on your page?
I'm gonna do this one. So after this lesson is finished, I will put this one on YouTube.
Okay.
I
Sounds
didn't
good.
like second hours. That's why I'm sorry.
It's all right. I was just making sure.
Okay. Thank you. Who is this? Who's talking to me?
Michael.
Hey, Michael. It's coming. I'll be done with this class in like 20 minutes and then I'll upload it for y'all, okay?
Thank you.
All right. So those of you that are working on number 13, were you able to do all 4 of them? No? Okay. That's okay. We'll talk about them. Did you get A? Yeah, that one's not too bad. You're finding the absolute value of -9 minus 15, which what's that going to be? So you've got -24 at first, but the absolute value of that is 24. So 24 is the distance. Remember, if there's no line above it, it's looking for the distance. So you found the distance. Then it wants to know, well, what's the midpoint? Okay. You can either take that 24, divide by 2, which is going to be what? 12, and then you could go from here 12 units. So how would we do that mathematically? -9 plus 12. Okay, you could add that. So what's -9 plus 12? 3. Or remember, you could have found the average. So we could have said -9 plus 15 and then divide that by 2. So what's -9 plus 15? 6 divided by 2 is 3. So either way, you're going to get to the same spot. Okay, either find the total distance, cut it in half, or you're going to average them out, and that is going to be our midpoint. Okay, C. This one says point C lies between points K and L. It doesn't say that it's the midpoint, it just says it's between. It says the distance between points K and C is 1/3 of KL. What does of mean in math class? Multiplication. Anytime you see of, you're going to multiply. So we're going to do 1/3 times the distance between KL. What's the distance between KL? 24. So what's 1/3 of 24? 8. 8 units. So that means I'm going to go from -9 and I'm going to go 8 units because I'm not going to the midpoint. I'm just going 1/3 of the way, 1/3 of the way. So what's -9 plus 8? So C is at -1, which that would help if I put it on the negative side. And I'm going to label that C. I didn't label the midpoint. They didn't tell us what to label it, so I just left it as a dot. But this is the midpoint. I guess I could draw this and say. But C is 1/3 of KL. Everybody okay with that? Well, then this one goes even further and makes it even a little bit more difficult. It says point N lies between points C and L. So C and L are here, and we're looking for the distance between the points C and N is 3/4 of CL. So we're going to multiply 3/4 times the distance between CL. Well, can we find the distance between CL? Sure. We're just going to do the absolute value difference. C is at -1 minus L, which is at 15. C minus L. So what is -1 minus 15? What's the absolute value of -16? So I'm going to multiply 3/4 times 16. What's 3/4 times 16? And if you, like, I know y'all don't have calculators in front of you, like flashback to elementary or to middle school, remember you can simplify using cross multiplication. 4 goes into 4 one time, 4 goes into 16 4 times. Remember that? And then you're just multiplying 3 times 4, which would be 12 over 1, which is just 12. But you can use a calculator. Like, it's not, I'm not going to be offended. So this is going to be 12 units. So 12 units from C. So I go to C, which is at -1, and I'm going forward 12 units. So where is N going to be located at? At 11. Does that make sense now? How to get all of those? Just remember that the word of means to multiply. So you're multiplying that to get your answer. Okay? All right, so that's all that. Now let's move to the algebraic side of the midpoint. So go to page 43 with me. All right, page 43 says you can use the definition of midpoint and properties of algebra to determine the length of a segment. Okay, so we're going to be determining the length based on their definitions. So if we look at example A, it says if Q is the midpoint of PR. I'm going to sketch that out just real quick. So we've got our segment PR, and it tells us that Q is the midpoint. So then they say PQ is 4x minus 5, and QR is 11 plus 2x. What do we know about these two segments, PQ and QR? We know that they're congruent because Q is the midpoint. So since they are congruent, that means we can set them equal to each other. So we just take this expression that represents PQ, the expression that represents QR, and you solve it algebraically. Okay, so we get that x equals 8, but that's not what we're looking for. We want the length of PQ. So plug it in, and then you get 27. Now, once you know that one of the small segments is 27, you know the other is also going to be 27 because they're congruent, and then you can add those up to get the entire segment. Okay, so let's do some on our own. All right, try these A. If Y is the midpoint of WZ. All right, let's draw WZ. Y is the midpoint. Okay. It says YZ is x plus 3. And WZ, this whole thing, is 3x minus 4. Determine the length of WZ. All right, do we have enough information right here to do this? Yes, because what do you know about a midpoint? I didn't mean to write X. You know that WY is congruent to YZ, right? So if this is x plus 3, then what's this? It's also x plus 3, okay, because they are congruent. So what you can do now is you can go back to segment addition postulate, and you can work that out because now you know all of the pieces, because the midpoint tells you that those are both going to be the same. But what if I didn't want to write x plus 3 plus x plus 3 equals 3x minus 4? What's another way that I could do that? Yeah, you could do that as you're working, just combine, or multiply by 2. Okay, so that's just another way for you to do that because you've got two of those. So we're going to use our distributive property. That equals 3x minus 4. Is it going to matter one way or the other? No. Okay, it's not going to matter one way or the other, but I do want you to see that distributive property so that you'll know you could just double it, just like that. Then you're going to solve algebraically. So x equals 10. Now, does that answer the question? What do they want to know? They want to know the length of WZ. So we have WZ's expression. So how do we find the length? Plug in our x that we just found, which is 10. So what's 3 times 10? 30 minus 4 is 26. So that's one way that you can do it. If they give you the expression or the distance between the endpoints, then you would want to double the smaller section. But the other option is just setting it equal to each other. So you've got to just see what's going on. So let's look at B and C. We're going to just set these up. I don't think we're going to have time to work them out, which is fine, but we are going to set them up, okay? On B, it says, right above it, it says given M is the midpoint of RS. Use the given information to find the missing values. Okay? So my segment is RS. My midpoint is M. This one says RM is x plus 3 and MS is 2x minus 1. So this time they didn't give you the whole measurement. They didn't give you the distance between RS. They gave you the two littles. So what do you do when they give you the two smaller parts? That's right. They are congruent. So you just set them equal to each other. X plus 3 equals 2x minus 1. And then you would solve. Okay, once you solve, then you could plug in to find out you're missing. Okay, over here, I'm going to do C. So same situation, RS, M is the midpoint. This time they tell you that RM is x plus 6. And that RS, the whole thing, is 5x plus 3. Can I set those two things equal to each other? No, those two things are not equal to each other. How am I going to work this out? Yeah, I guess you could subtract that way. You could take this segment and subtract that one out. That is going to still not give us our answer, though, because then what would we set it equal to? So that wouldn't work. That's exactly right. Since M is the midpoint, this one is x plus 6 as well. Good. Once you know that, then you just work the problem out. Or you could simply say, I'm going to double this because it's the midpoint and set that equal to 5x plus 3. And then you would solve it out algebraically. All right, right below that it says, when you bisect a geometric figure, you divide it into two equal congruent parts. We will be using this like forever, okay? We will be cutting things in half the rest of the school year, okay? So we'll have all kind of bisectors, angle bisectors, line segment bisectors, tons and tons of bisectors. What you're doing is you're cutting them into two equal parts. 14 says line segment WZ bisects the line segment XY at point Z. What are two conclusions you can draw with this information? Okay, so the first thing I'm going to do is I'm going to draw X, Y. Okay, that's this. It is being bisected by WZ at point Z. So if it's being bisected, what are they doing? Cut it in half. So the halfway point is going to be Z. And then I need to draw the other segment. Does that make sense? So you've got segment XY is being bisected by WZ at point Z. Okay? If they wanted more than one, you could just draw it this way. You could draw it upside down. Could draw it lots of different ways, but it's all going to look the same way. You're still going to have this segment being cut in half by that segment. Okay, so that's what it means to bisect. You've got to remember that word so that you can use it for the rest of the year, actually. All right, check your understanding. I don't think we're going to get through all of these. Where are we at time-wise? Yeah, we need to close it in just a second, but let's at least look at number 15. If you look at number 15, it says, explain how to find the distance between 2 points on a number line. What do I keep telling y'all to do to find the distance between 2 points on a number line? Perfect. Absolute value difference. Does it matter who's first and who's second? No. The absolute value will fix it. Okay, it doesn't matter who you start with or who you finish with, it's going to be the same. All right, 16 says, how would you say that name? Mackay? We'll go with that. Knows that GH is 7 and HJ is 7. Based on this information, he claims that H is the midpoint of GJ. Is his claim necessarily true? Make a sketch that supports your answer. Could it be true? Yeah, it totally could be true. Okay, so we could have a situation where we've got, what is it? G and J, and H is the midpoint. Okay, so could totally be true. Is there a way it could be false? What if we went this way? And this is G, this is H, this is J, this is 7, this is 7. Would H be the midpoint?
Just a reminder, Jackie, we will stay in class during the second lunch shift. You can't come to the cafeteria and get a lunch. You can pick up concessions. The Jack's Java will not be open during the second lunch shift today. Thank you.
Why is that not the midpoint right there? Well, yeah, it could be an angle, but yeah, it's not a line segment. Okay, GJ, it would have to be connected like this to be a line segment. Okay, so that GJ is not a line segment. Okay, so we're not dealing with a line segment there. So there would be something that proves that false. Okay, we are good with the next two. We're totally fine. So your homework tonight is 19 through 24. What do you need to submit to me to get full credit? Notes and homework. Notes and homework is what you need to submit to me to get full points for today's assignment. Make sure you do the attendance question. That's what I need from y'all today. Anybody have questions? Okay, y'all have a good rest today.